Hello, this is Ms. Nichols, and I'm giving you just a quick recap. Hopefully you have checked your notes already and gone through those, but this is a quick recap of variables, units, operators, and mathematical relationships portion of the exam. So as a reminder, variables are really what physics is all about. And so to understand the world, we try to put numbers on things. We try to measure things in numbers. And there's a ton of things in the universe you could measure. You probably did some experimentation and found a relationship between variables in your house. But in general, the two variables that we've learned about so far are mass, and we talked a little bit about time. Those are the two that we use mostly in this unit. So mass is a generic variable. It can describe lots of different nouns, lots of different things from your life, right? You could see the mass of this pen, the mass of your computer, the mass of the blanket that you're wearing. There's lots of objects that a question can be about. But in physics, we only really care about the property of that object we can measure. So I don't care about the blanket, the pen, the whatever. I don't care the specific object that it's about. Those things in physics aren't anything important. What we do care about is the mass of that object or the properties that we can measure. So if we're looking for a variable, it's usually going to be something measurable, like, for example, mass or time. When we find variables, we want to make them easier to write because we're kind of lazy. So we have what's called a symbol. And the symbol for mass is M, and the symbol for time is T. When we do take the mass of an object, you should be able to say, like, what tool are we using, right? If we're finding the mass of a blanket or a pen, you probably use some kind of scale. And when you put it on the scale, it's going to spit out a value. So that's like the size of the mass. So for example, the mass of this pen on the scale might be something like 40 grams. Okay, and that word grams is the unit, which is the thing that we're measuring the variable in. There's a couple different units you could have for mass. It could be grams, it could be kilograms, it could be pounds. There's lots of different possible units. It depends on the object that you're measuring, what would be appropriate. Like, I wouldn't want to measure the mass of an elephant in grams because it's really, really heavy. So you want to pick a unit that's reasonable for your object. Time could be measured in minutes or seconds or hours, depending on what you're using. And of course, the value for this is going to be some sort of number as well, depending on what it is that you're measuring. So in general, moral of the story, variables are always going to be, specific things that we've done in physics. They're never going to be like a noun, an object, a color, a person. Those are not variables because they can't change. They're not numbers that can change. What are variables are things like mass and time. All right, the second portion of this portion of the test is going to be about the mathematical relationships. And we learned about two of those primarily. And those two are linear relationships or inverse relationships. Let's focus on the linear first. When you have a linear relationship between two variables, it means that variable one goes up, is increasing, or goes up. Sorry, my handwriting is bad, but hopefully you guys can listen at the same time we're talking. And that is going to cause variable two to go up as well. Okay. So the example we gave in class was something like, the more people in the classroom, the more shoes we have in the classroom. It makes sense, right? Every time we add people to the classroom or double the number of people in the classroom, the number of shoes you have in the classroom is going to double as well. When you make a graph of linear relationships, it's going to, be a straight line of some kind. It might be up here, it might be down here, it might be steep, it might not steep, but the data points are going to create a graph that is some kind of straight line. And the reason that they do that is because if this is variable one down here, and this is variable 2 on this axis, right? As variable 1 increases, goes up, you'll see the value of variable 2 goes up as well, right? Each of these graphs, as one goes over, the other one goes up. As one goes over to the right, the other one goes up. That's always the way we're going to see those variables trending with each other when we are talking about a linear relationship. Both variables are going to go up. The other kind of relationship is the inverse relationship. And inverse is the opposite from linear. When we have variable 1 going up, it causes variable 2 to go down. And it's a little bit trickier to find examples of inverse relationships in the real world, but we'll see some more as the year wears on. But the example we gave in class was something like a pizza or a bowl of food that you're sharing, right? If you have just one person, they get all the pizza. But if it's 2 people, so if people goes up, so people went up here, right? Now the pizza that each person gets is going down, right? So now instead of getting the whole pizza like you got by yourself, you only get half the pizza. And if I have 3 people, so I have even more people, now I'm getting even less pizza, right? So that's how we sort of see inverse relationships. When we look at those things on a graph, it's kind of interesting. Like picture you have, this is 1 pizza for 1 person. If I double the number of people, so this is people, and this is pizza. If I double the number of people, I now have half as much pizza. And if I double the number of people again, up to 4, I have half again as much pizza. You can't really have half a person, but anyway, what you would see if you made this graph is that the less the people you have, the more the pizza they get, and vice versa. So it actually makes this interesting graph that sort of looks like this. It's not a straight line if you have enough data on it, and it never crosses these axes, which I'm going to come back to next. Okay. The last thing that you should make sure that you can talk a little bit about on these graphs is what is known as the intercept. Specifically, well, all the intercepts, but on my graph, we have 2 axes. This is known as the x-axis, and this is known as the y-axis. The intercept of a graph is where the graph hits that axis. So this graph I've drawn right here, this value, whatever it is, let's say this is 5 and 10 of whatever is on my y-axis. This value right here is my y-intercept because it's where my graph hits the y-axis. And the y-intercept happens when the x value is 0. So when you see an intercept on a graph like that, you can say something like, if variable x equals 0, variable y equals, in this case, positive 5, because, and there should be a reason why that sort of makes sense. Some other graphs actually don't have intercepts, like for example, our inverse graphs don't have any intercepts, which means, right, this one never crosses this x-axis. It never hits the x-axis, and then the line never hits the y-axis either. It just gets closer and closer and closer, but it never actually kind of gets to that line. And so you should be able to say something like, there are no x or y intercepts because, and then there should be some logical reason why there isn't. In the example of the pizza versus the people graph, pizza would never be 0 because you always have some pizza, and people would never be 0 either. Otherwise you wouldn't have the people sharing the pizza, right? So it doesn't make sense for either of those variables to ever equal 0. Therefore, the graph should never cross that 0 line on these axes. So inverse graphs don't actually have y-intercepts. All right. So that was really quick. Hopefully this is a review and a recap, and you or your partner, if you've got one on this retest, will be able to use some of these notes plus your old notes to try to figure out what's going on in those questions. Thanks for watching. Good luck.